And my name is Dario, so I'm a senior engineering manager looking after platform engineering teams at a company called Optum UK. JP, shout out to JP, who's a member of the community over there, has got me up here with a day's notice, so apologies if this doesn't go as smooth as planned. But I'll start by saying, like, what brought us here? Why am I even here? Why do we have anything interesting to share? I think I'm not going to blow your socks off with some, hyper-technical conversation around AI and how we've implemented AI or we've implemented some cool new technology. But I do have an interesting story to share about our setting and how we've got more probably out of, and as to some of the presentations earlier, more out of simplistic tools, how we've started to get more consistency, more accuracy from our AI tools, and create a little bit less of a Wild West ecosystem. And I touched on there about the industry we're working in particular the health tech setting. It's probably not dissimilar to some of the settings that you guys work in, banking, heavily regulated. But our organisation is fairly unique in its journey from being a really small company that started in 1988 when I was born, and was, I think, two GPs in North Yorkshire, to being part of a huge multinational American corporation. And the settings in which our software is represented is huge now compared to where it started out. So we've got software right from primary care through to A&E and everywhere in between. In terms of those regulations that I mentioned, they're just vast, right? And there's a lot of bodies that we have to interact with, a lot of certifications, assurances we have to go through. And we have to build confidence with them bodies as well, which isn't always an easy task. But it's justified, right? Because the data we're looking after is your data. It's the country's data. It's beyond the country's data now. And it's not just the data that we hold. We hold most of the UK's patient medical records, but it's how we use that data as well. It's the clinical decisions that are made on the back of that data. We have we inform research program. Was the mic gone off?
Just trying to hold it a bit close to you guys.
Testing. So our data informs research projects as well, in terms of good candidates for research programs. And I've put on there a 25-year tech landscape, but that's probably optimistic. The tech within our sector is just sprawling, and within our organisation, it's sprawling, right? It's evolved over a long time. And we have plenty of skeptics. Skeptics isn't something that's been touched on that much today, I don't think, but particularly around AI, I'm guessing there's a fair few AI skeptics even in the room. But uniquely for us, within our organisation, we actually have clinicians embedded working on our products to inform them. And they're not just clinicians that are qualified and hired by us. These are clinicians that actually practice every day. So they're thinking from a point of view of how am I going to actually interact with patients with AI versus how we're just going to incorporate it into our software development lifecycle. And again, that skepticism is justified to me because the stakes of us getting things wrong are not just inconvenience to a consumer. It's actually, people's lives. It's really serious. So that's why I think that our journey might be quite interesting. And I'm going to try and tell it as a journey as well. So to start off with, what happens when you unleash Copilot in an unregulated environment? Strategy, what strategy? What I'd say on that is, I don't know if this was mirrored in other people's organisations, but certainly within ours, initially there was a real contrast. At an organisational level, we jumped to governance and guidelines, but really around the procurement of tools rather than the implementation of them tools. So we had bodies spun up to define ethics around how you use AI, and then we had training courses on how you should interact with AI. But then they said you can use this one model and this approved tool. So they were very restrictive, but on the other hand, within the confines of the tool and the data you had access to, there were no rules. It was experiment, innovate, do what you want to do. And so we did, right? So the first thing we looked at is, how do our users engage with our software? How could we improve their experience? What challenges are they having? And if you think in terms of the people using our software, it's clinicians and patients. And so we were looking at, cool, could we summarize a medical record? Could we get insights straight to the GP at the beginning of the consultation? Could we transcribe the conversation and pull out readings and insights and really help the GP? And we did build some of that stuff, right, really quickly, and it was cool. And everyone said it was cool, but then they asked us, is it right? And that was a massive problem for us. And it's a problem that we see within, AI in general, right? And that's why there are tools like DeepEval that exist to try and assess the accuracy of the responses that are coming out of large language models. So we looked at some of that tooling. We had a play with some of that tooling. But again, we realized we're a little bit unique in that we have this knowledge within our business on the clinical side of things. Our clinicians know probably better than anybody how right or wrong the summary is, or how right or wrong the model has got this. And we decided we needed to build something internally. But we've got this AI tool, and we can do whatever we want with it within reason. So we tried to do that. And to use probably harsher words than there, it was the code quality was shocking. It came out crazy, and we weren't very happy with it at all. So how do we solve that, or how did we start to solve that, move towards solving that? We had to ask ourselves, how do we inject some purpose and some scope into the model? How can we give it the ability to essentially constrain itself to be more reasonable in what it produces? And that starts with standards, right? We said that the code quality wasn't good, but we must have had something to measure it by, even if a gut feel, right? And as most organizations, our standards are here, there, and everywhere. And depending on the age of the technology, it might be a really sleek codified solution, or it might be some tribal knowledge in some guy's head in an office somewhere else in the world. So we had to extract that, and we had to think about, well, how do we then inject that into the model? How do we give the model access to that context so that it can act in an appropriate way? Now, there are a multitude of technical ways we can do this, and the last few years, there's been a heavy push towards different ways of doing it. And we did have a play with some architectures, whether it be like RAG databases, that type of stuff. And what we really realized is we're probably overcomplicating the problem, right? We've got these tools that are available to us right now, essentially driven by markdown files, and we're looking at building databases and cloud infrastructure to host them databases and extracting data from different tools and centralizing it. So we started with agents, and we started with agent skills. You may have, most people have heard of agents. We tend to think of that as a behavior or a persona in which the model's going to operate within. But when it comes to skills, there's great support at the minute for agent skills, which is an open standard that Anthropic pushed originally and has become kind of the de facto. And so we started to codify the knowledge that we had within the business, and we started to experiment on some of our more modern stacks with these skills. We started to create a library of these that were shared so that we could drive a bit of a community approach to improving these skills. And on screen you can see an example of an agent and some skills that it might pull in. So I'd think of the agent as the orchestrator, the personality, and I'd think of the skills as the implementation detail. And what we found was we went quickly from having a really, really Wild West type code generation to having quite a controlled code generation, much more aligned with what we would expect a developer to create in the real world. But it wasn't perfect. One of the great things about the agent skills format is that it's simple, and that LLMs can process it easily, and that these skills can be pulled in when needed to reduce the amount of context we're pushing into the model. But the body of the skill itself is still a Wild West. It's just Markdown. And most people write it as a series of steps, 1, 2, 3, 4. And so we were telling our LLM, you're acting in this persona, do this task, and follow this process. But LLMs like to add a bit of spice to the process, a bit of diversity in there. So we started getting results that we weren't really expecting. And we actually came up with a very simple way of controlling that within our business. So we started to define a consistent Markdown structure within the body of the skills to basically define rule sets. So having this consistent meant whatever the skills we were creating would work in a similar way. They'd be structured in a similar way. We could build tooling on top of them to work in a similar way. And as you can see from this example, this is actually a real example from our authentication skill. We've built an auth provider, we've built an auth solution. People need to integrate that into their microservices. There's certain things that they need to be doing and not doing. Whereas the skills will go away and try and implement things. With the rules in there, they'll actually try and conform to standards as well. So not just implement, but also control themselves. And we found, again, a bit more success with this. Now you can see we've got a bit of metadata in there around type. What we also realized as another lesson was when it comes to guardrails, well, when it comes to checks or rules, there were two types. There were the type of thing that you could deterministically test, a binary pass-fail. Have they done this? Have they done that? And then there were subjective rules, maybe things that a human would interpret that a machine would struggle to. And as per that description there, if you can write a test for it, we treat it as a guardrail. If you can't, it's a steer. In most cases, we have guardrails, but there is the odd steer. And what we want our steers to do is provide evidence that will support that decision making from a human point of view. So if you think in terms of governance rather than maybe a technical skill around clinical safety, there might be something that's a little bit interpretable where we need a clinical safety officer to actually make that judgment call. So we've got to a point now where not only are we using a model to try and make code, and it's spitting out code, we're actually getting it to implement things in the way that we want to implement things and getting it to constrain itself so it doesn't get distracted and create random pieces of code. But we still come back to that same problem, right? How do we trust what the AI produces? We could even ask the AI, and we did think about this, did you follow all them rules? But it might have said yes when it didn't. And that's the reality of models, they're just black boxes. Instructing somebody, just like a human, to follow rules doesn't mean that they will. If somebody tells you that they've done something with confidence, it doesn't mean that they've done it correctly. And in our space, we just can't accept that, right? We can't have it not doing what it's meant to do. And the other purely pragmatic side to this that you guys might have experienced is accelerating the production of crap code just makes us slower as a business anyway, right? Because we all get bogged down in peer reviews and we end up reworking this anyway, which is a big frustration when people haven't guarded their AI. So we introduced another layer downstream that we call guardrail analyzers. So these are really lightweight containers where we use technology from the particular ecosystem to run the guardrail checks for us. So we almost allow the LLM to offload that task when it's written some code to say, okay, now check it, but I'm not going to check it. You check it, you guys that can do it properly. And these containers produce a standard output basically that is machine readable. So it can be fed back into the LLM, and the LLM can say, oh God, I got that wrong, like a human would, and it can address the problem. And so we actually started to create a feedback loop between the AI and something more deterministic, so that the AI could get to a better first pass. And as I mentioned, we haven't removed those checks that we already have in our CI that are already part of our lifecycle. We haven't taken our integration tests out, static analysis test checks out. We haven't removed the human from the review process. But what we have done is get to the point where the first commit from the model is better than it would have been, if we were just using the tool raw. But we talked a lot about community as well today and about contribution as a broader topic. And so we wanted to look at, well, how do we even make this smarter, right? Because I'm not a clinical safety officer. No one in my team's a clinical safety officer. We're not IG experts. We're not even database experts. We're just kind of jack of all trades, if we're honest. And so one of our first tests of how well we'd constructed these skills was to start raising PRs into some of our team's repos and telling them we've done it. So we'd pick up a feature, chuck over a pull request, and say, this is great, we've done all that work that you said would take ages, what do you think? And as you can expect, the response wasn't great, but it did get quite far, right? And the engineers, even some of our more resistant engineers, had to admit that, to be honest, it's not bad, right? There's just these things that we need to improve. But we now had a framework to build on, right? Because we'd encoded this knowledge. So we were able to say to the engineers, well, yeah, the auth pattern's wrong. Let's just encode the right pattern then. Let's correct it. It's all stored in GitHub. Let's update it. And so this model started to produce more and more reliable results for us. And I talked about community. This is all in a source now. So we open this up first to a working group and then to a broader set of people. And all of these elements within this hierarchy of tools we see it as codified knowledge that will eventually replace a lot of the documentation that we have out there in the department. And people are free to contribute and argue over PRs as to what is right and what is wrong in there, but it's everybody's. And we have seen a massive increase in contribution. So when we first started, we did probably 10 to 20 skills on the latest, easiest technology to work on. We've now got more than 70, and the vast majority of them have come in from different parts of the business and are specific to maybe technology that they're working with. And to that point, that domain knowledge is now in an engineering wrap, so we can build on it, right? It's versioned. We can build tools on top of it. We can interrogate it over time. We can point people at a single place to get those docs. And so I'll quickly touch on a few case studies around how this played out in the real world. Some is funnier than others. One of our most, let's say, opinionated engineers within the organization was very quick to point out that it had generated some raw SQL in one of the pull requests, and we need to be using the ORM, and I'm not going to use that tool basically. So we said, good point, we encoded it into the guardrail, we updated the analyzer, and then we said, what if we test this against his code base? What do you think happened? Violations found everywhere, and in typical senior dev fashion, it wasn't his fault. It was some junior in the team, so he was going to kill everyone. Another example was, this was actually Luke, who was supposed to present today, 23-minute refactor before he started work. So one of the libraries we were using in one of our pieces of software went commercial. We had to rip it out, we had to replace it, we had to do it quickly. We just updated the analyzer that said that couldn't be used, told the analyzer to run against the code base, found the violations, set the agent running to repair the problem. A few interruptions in between, but 23 minutes later, all the files were changed, the tests were passing, and we were out of trouble in terms of that library. Migration no one wanted to tackle, so we had a team that had been avoiding, like the plague, migrating their .NET version because they had a few complications within the code base, and they'd estimated 2 weeks worth of a full team's effort to do that confidently. It actually got done in an afternoon whilst the engineer was in meetings. It didn't do it perfectly though. We did introduce a regression, a performance regression, and an engineer caught it and fixed it. So just an example there, this isn't to replace people, it's not perfect. But what we did find is it was a lot quicker than 2 weeks in a full team, right? And going back, full circle to the clinical evaluation platform that I mentioned right at the beginning, That entire platform pretty much has been built now and is in production within a 2-month timescale from nothing. And the main contributor to this is an architect who hasn't really written code, even in these languages for a long time. 72% of all the commits are AI generated, but the quality is there. The other engineers can see that. And so that skepticism is starting to die down a little bit. So what would I say you could take away from this conversation? Use AI for speed, but you need to be embedding deterministic tests to trust this, right? It's not going to replace the tests you already have, and you probably want to get some kind of feedback to the LLM as quickly as you can. Encode your rules as code. So if you've got standards within the organization, get them to the LLM, right? Let it use them. Don't trust AI to validate AI. So on that first point again, even if you do have rules, even if you do have some structure to telling what the LLM to do, don't trust it to mark its own homework. You need to go outside of it for that. Let domain experts write the rules. Central team can't do all this, just like everything in platform engineering. You need to democratize the process. You need to bring people in. And as much as anything, you need to let them have a stake in this so that they trust it. Start with the pain. AI is moving that quickly. The tools are changing that quickly. If you try and build a roadmap, you're gonna struggle. You're gonna have problems within your enterprise right now, though. So there's a starting point there, right? What problems can we solve? The problem we were solving was this need to control our outputs, but it ended up solving many other problems at the same time. Bring your skeptics in. They're the ones that are going to ask the hard questions. Don't alienate them. Don't see them as people that are rejecting AI. They've probably got a good reason to be skeptical. Bring them in, make them part of this, make them see the improvement and have a stake in it going forward. And that's it from me. So thanks.